I welcome you all for this lecture series on artificial intelligence and machine learning. In this lecture, we'll discuss about introduction to probabilistic reasoning and Bayes theorem. We'll see one by one. The probabilistic reasoning is a powerful method of knowledge representation that leverages probability theory to handle uncertainty and incomplete information in real world scenarios. So, if you are considering what is the purpose, we will see. Unlike the classical logic, which deals with the absolute truth and falsehoods, probabilistic reasoning assigns likelihoods to events. So, in classical logic, we will get it as no absolute truth or falsehood, either 0 or 1. But in the probabilistic reasoning, it assigns the likelihood to events, helping us to make informed decisions even when the outcome is not guaranteed. This approach is particularly useful when data is uncertain, ambiguous, or only partially known. The primary purpose of this probabilistic reasoning is to predict outcome in uncertain situations. Uncertain situations. It enables the decision making by quantifying uncertainty and assigning values to potential outcome. For instance, we often face situations where outcomes cannot be predicted with complete certainty, such as whether it will rain today. So we can call it as whether we can rain today, or how someone will behave in different situations, or who will win a match between two teams or players. In all these cases, probabilistic methods or models analyze available data and compute the likelihood of different possibilities, and allowing us to make more rational and informed choices instead of giving zeros and one, truth or falsehood. So, in essence of probability theory, in essence, the probabilistic reasoning combines logic and probability to model complex system where the certainty of events are not absolute. It finds applications. So, what it will do is applications in diverse fields such as artificial intelligence, medical diagnosis, weather forecasting, and robotics, making it an essential tool for addressing uncertainty in decision making process. So here and in the probabilistic reasoning, need for probabilistic reasoning is in AI is when there are unpredictable outcomes, when specifications or possibilities of predictions becomes too large to handle, when an unknown error occurs. So if you are doing an experiment, unknown error occurs during an experiment. If you are getting any unknown errors, this probabilistic reasoning will be helpful to solve that. So in probabilistic reasoning, there are two ways to solve problem with uncertain knowledge. What are they? The by using the Bayes rule or Bayesian statistics. Bayes rule or Bayesian statistics, we can able to solve the problem. And the what do you mean by probability? The probability can be defined as the chance, can be chance that uncertain event occurs. It is the numerical measure of likelihood that an event will occur. The value of probability always remains between 0 and 1, and that represents the ideal uncertainty set. So the probability value is always between 0 and 1, that we can represent it as P of A is equal to, that is 0 less than or equal to P of A less than or equal to 1. What is P of A here? The P of A is the probability of an event. And the probability of A equal to 0 means it indicates a total uncertainty in an event is that is uncertainty in an event, and P of A is equal to 1 indicates the certainty in an event. So the probability of, if you are adding all the values, you have to get 1. The probability of an uncertain event by using the below formula, probability of occurrence is equal to number of desired outcomes divided by total number of outcomes. We'll see the problem in this case. And the probability of A bar, this represents the probability of A bar. It's not happening an event. If you are adding probability of A bar plus probability of A, always you should get the values equal to 1. And here we'll have some definitions. Event means what? Each possible outcome of a variable called as event, and sample space. So if you are taking the die, die if you are rolling out, will have the sample space. It contains the value 1, 2, 3, 4, 5, 6. So the collection of all possible events is called the sample space. And what do you mean by random variable? The random variables are used to represent the events and objects in the real world. Here, the prior probability and the posterior probability, we are defining very important two probability definitions. The prior probability of an event is a probability computed before observing new information. The probability that is, and this is what a prior probability, and the posterior probability means the probability that is calculated after all even evidence or information has taken into account. It is a combination of prior probability and new information. And here, if you are taking this Venn diagram, this is the event A, this is event B, and if you are drawing the graph like this, you'll get here this is A intersection B. Conditional probability, this is the conditional probability. Conditional probability of occurring an event when another event has already happened. Let's suppose we want to calculate the event A when event B already occurred. The probability of A under the condition probability of B, it can be written it as probability of A given B is equal to probability of A intersection B divided by probability of B. One more time I'll tell you, the probability of A under the condition B, it can be written it as probability of A intersection A given B is equal to A intersection B divided by probability of B. And next we'll move on to the Bayes theorem. This Bayes theorem is also known as Bayes rule, Bayes law, or Bayesian reasoning, which determines the probability of an event with uncertain knowledge. This uncertainty, this word is very, very important in artificial intelligence. In probability theory, it relates the conditional probability and the marginal probabilities of two random events. And the Bayes theorem was named after the British mathematician Thomas Bayes. The Bayesian interference is an application of Bayes theorem, which is fundamental to Bayesian statistics. So here, if you are given with the probability of B given A with the knowledge of probability of it was found by probability of A given B. And this theorem allows updating the probability prediction of an event by observing new information of the real world. So say for example, if you are taking, if cancer correspond to one's age, then by using Bayes theorem, we can determine the probability of cancer more accurately with the help of age. And the Bayes theorem, and we are going to get it as by using the product rule, the conditional probability of event A with the known event B. Known event, we are considering event B as the known. So it is given by probability of A intersection B is equal to, the previously we have derived the formula, no? Probability of A given from this formula. Probability of A given B is equal to probability of A intersection B divided by probability of B. So from this we will derive probability of A intersection B is equal to, what is the value? Probability of A given B into probability of B. And similarly, probability of B given A is equal to probability of B given A into probability of A. So from the previous formula we are deriving. And equating the right hand side of both equations, you are going to get, what you are going to get, probability of B given A into B is equal to probability of B. So if you are equating, some of the values will be getting cancelled and you are getting probability of A given B means just ulta. Probability of B given A into probability of A divided by what is the value is there? Probability of B. This is very, very important when you are solving the problem. This Bayes rule, or this is the Bayes rule or Bayes theorem. This equation is the most basic equation in AI, is basic of most modern AI system for probabilistic interference. So probability of A given B is equal to probability of B given A into P of A divided by probability of B. So what it shows means, it shows the relationship between the above equation, simple relationship between joint and conditional probabilities. Here probability of A given B is the posterior, which need to be calculated, and it will be read as probability by hypothesis A when occurred an evidence B. And the probability of B given A is called the likelihood, in which considered It is considered that hypothesis is true, then we calculate the probability of evidence. Probability of A is called the prior probability, probability of hypothesis before considering the evidence. And this probability of B is called the marginal probability, otherwise we are calling it as the pure probability of an evidence. So the Bayes rule, if you are applying, if you are given with the probability of B given A in terms of probability of B or probability of A given B, probability of B, we can able to write the expressions. So in this case, suppose we want to perceive the effect of unknown cause, we want to compute the cause, then the Bayes rule becomes probability of cause given effect is equal to, how we will going to write, probability of effect given cause into probability of cause divided by probability of effect. So one more time I'll tell you. Here, if I am given probability of A given B is equal to probability of B given A into probability of A divided by probability of B. This is what to be the Bayes rule. So by making use of this equation, we'll solve the problem in the next lecture. Hope you understood about the Bayes theorem and the probabilistic reasoning and Bayes theorem. The remaining things we'll discuss in the next lecture. Thank you.